hey, reflection server, can you get to this? And this is where the reflection server, the position of the reflection server comes into the game. The reflection server is in the DMZ outside the inner firewall. For this reason, the reflection server has the same access rights as everything outside the company and inside the internet. We have also an outer firewall that not everybody is able to get to our reflection server, and also maybe to sniff this traffic. You don't want to route all your traffic through the internet. And in this case, the reflection server tries to get to the internet web server. The inner firewall says, no, 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 what are you doing? And so the reflection server denies this request, and we see a warning maybe, or maybe we don't see nothing, anything. Depends on the case. So this was actually doable. With HTTP authentication, we had even bigger problems. Simply removing the authorization header doesn't work. And this kind of sucks, and I'll show you why that is. We have the client, we have our proxy in the middle, and we have the server. And the client has an untrusted request that somehow has an authorization header by browser magic. If we simply remove this authorization header and send it to the server answers with 401 unauthorized, and we would pass that 401 unauthorized to the user. The user enters, hi, I'm Martin, my password is foo. And what is then done, the browser automatically just simply creates a new request to the same resource, and the authorization header is completely the same as well, because the credentials have not changed. So on the proxy side, we have no way to differentiate between the first and the second request. For the proxy, they completely look the same. And if we just say, okay, we have removed some authorization header to the server, so this one must be authorized because we have now implicit authentication, we run in timing problems, because the malicious guy can try to create a lot of those requests before this dialog is shown up, and then we are hacked. So we can't do that. Therefore, we have to do some magic again. Okay, again, we see an untrusted request that has an authorization header. Instead of removing the authorization header, we first answer with a 301 move temporarily. And we go to the same resource, but in this case, we add our little tag. So then we know, okay, this request that now is created because we sent the 302 move temporary and because we removed this authorization header. The web browser itself doesn't know that anything has happened, so the web browser thinks, okay, this GET request was okay, therefore he again adds the authorization header. But now we are able to remove the authorization header, and then we have two options. For one, we can just pass it on to the server, or we just answer ourselves with a 401 unauthorized. We've implemented both solutions, and this is more convenient, so we do this. Or actually, we do the other one. Which solution do we? You have to look in the code. It's open source, but it works. And now, with a 401 unauthorized, here comes then enter your credentials, and this authorization header we know we can trust, because in this case, now we have our tag here, and with the tag we know, okay, this tag and this authorization header can go to the server, and the server can send us the restricted data. Okay, last page before the demo. Cross-site request forgery is a big problem, and even if Mozilla doesn't think so, we think so, and I think the past has told us right. Therefore, if you do web applications, use nonces, and if you use a web application and you don't use request rodeo, use one application at a time. Don't use Firefox with 50 tabs on, and every tab has some authorization information. This is something you should not do. And also reject long-lived cookies. If you use Gmail, log out afterwards. Okay, Gmail is not vulnerable right now, but there are others, so be careful. Okay, now, well, we still have like 50 minutes, so let's go to the demo.
Okay. Okay, this is our proxy. just a simple Python script. And we switch to it. Great. And I can show you 3 things. The first thing is HTTP stuff, HTTPS stuff. So I will go to this one. It's an HTTPS stuff site, and just watch closely. We get an intermediate site informing us what's going on, and because we send along some JavaScript magic, it's a completely automatic process. It shows the page, it authenticates, it initiates SSL connection using the embedded image, and it does some polling using XML HTTP requests, and if the proxy says, okay, the handshake is done, it will forward to the original page. So watch closely. This is the image. Oh, it's a slow computer. It's great to see. So now we have HTTPS over HTTP. You can see the port here. And we actually insert some HTML code to inform the user what's going on. And because I entered the address, there's no referrer to it. So it removed any cookie. I hope there wasn't any. And if we hover one link on the page, you see this is our tag for the page HTTP events congress ccc.de port 443 Congress 2006 Lightning Talks. So if we click on any link, we have this tag here. The proxy knows where we came from, so it says, okay, I have a reliable referrer, it's okay. So, now to the bad stuff. Okay. If I hover another link, you can see this is not the same value as reload? Escape. Yeah, great. As this. Okay? It's just a random number. Okay. So, I have this test page on session writing. It's actually very simple. I click on a link on the domain winter.goddns.org, and it's just a PHP script that sets a header and cookie. So it's there. I go back, and I click on the post or get request. It's just in simple form on a PHP script that tries to get the cookie back. And there isn't any. Anyone tried it? No one? Great. Okay.
If you don't believe us, try it at home.
I can show it with the Firefox plugin. So, and if we hover our little div, the proxy informs us that there was something going on. We switched domains and it removed the cookies. So, we're safe. And just to show you that HTTP authentication is also handled by our proxy, I will log in here. It's just an HTTP basic authentication. Yeah, we want. Oh, okay, it's just foo and bow. So now we are authenticated. Let's head back and try to follow a link. And HTTP GET request to another host. And if we are authenticated, still authenticated, our session would have been written. Let's see. And now it actually requires us to enter new credentials explicitly. Okay, we say cancel, and it's done. There is this Firefox plugin I mentioned. It's here, down here. Great. It's a prototype, but it is able to remove cookies. So let's see. Just reload this page. Ah, crap. So our little green box is gone, and we set this cookie here. It should be there, but just to be sure, it's set. This is the pure Firefox browser without our plugin. So if we follow a post request, there is the cookie, and this session has been written by the referring site. So let's enable our plugin. Some magic. And if we now try to get our cookie back, it's gone. We are safe. Yoo-hoo! Woo-hoo! Okay. That's it.
Yeah. Right on time.
Questions? Do we have a mic? Yeah.
With the proxy, if you go to a HTTPS site, you don't have the certificate anymore. So how would you be sure that you're on the right site and it's not a phishing site?
Okay, I'll just show you. I'll enable it. And I head over to an HTTPS site which hasn't any valid certificate, or I do not have the root certificate. So let's see. Sorry, Millie. So this is the page the proxy created, and there is this image that hasn't been loaded yet because we did not click on OK. So I'm in full control of whether to trust this certificate or not, because this image is loaded directly through an connect method. So I can examine this certificate, check if it's valid or not, if I want to trust it or not, and if I decide yes, I want to trust it, or if my browser decides to trust it because I have a root certificate, I say okay. And the handshake is done, the proxy monitors the handshake, and we get forwarded.
Yeah, but now you can't see anymore if there is a valid certificate. And
yes.
For normal users, we say check if you can see it in the URL bar and on the right side below the page if it's a phishing site or not. And what should the normal users do now?
Yes, that's right. That's a problem. We have some problems integrating our proxy into the user interface of the browser, and that's one of the things the Firefox plugin can do better, much better. And with this solution, if you just add some random HTML code to a page, this is totally spoofable. So our proxy implementation was more or less just a proof of concept implementation.
Also, I still have to see one of the average users that look at this thing in the border and knows what it does.